This is a revision video for triple science students only, and it's all about lenses. And what lenses do, they refract light. From an earlier video you can remember that refraction is when light changes direction from going to a denser medium. So we're going to start off with a convex lens, and that's where it bulges outwards. So from the centre of the lens to what we call the focus, principal focus, that distance between the centre of the lens to principal focus is called the focal length. And you may be asked to label this. So what a convex lens does is the light comes in and then it refracts to the principal focus. The light comes in parallel and then refracts going through the principal focus. You can see how they're all converging at that point. And if the light's coming in straight along the axis, it just carries on going straight through. So all those points are there. That is the principal focus. So that's a convex lens. A concave lens, instead of it bulging outwards, it curves inwards. That's called concave lens. And again, the centre of the lens to the principal focus is the focal length. That length there is the focal length, same as in the first video. But this time what happens is the light comes in parallel, but this time it diverges. Comes in parallel, but then diverges. Comes in parallel, diverges. Comes in parallel, diverges. If it's coming in along the axes though, it does just go straight through like that. And what we can do is we can dash these lines backwards to find out where all these lines meet. So we've dashed all these points backwards. I'm going to emphasize it there. Big giant blob, and that point is called the principal focus. That point there is the principal focus there. So that's a convex lens and that's a concave lens. So you need to know how to draw ray diagrams for images for them. So we'll go on to that now. And this may seem tricky, but all it takes is a bit of practice. So the first thing you need to know is we represent a convex lens with an arrow like this. So an arrow like that represents a convex lens. And there's our axes, and let's say we've got a person as our object. We've got our principal focuses there. First thing we do is we draw a line parallel to the axes. When it hits the convex lens, it refracts and goes through the principal focus. We also take a line from the top of the object going through what you would call the origin in maths. So it's gone through the origin, and what happens is the image is here, so where they cross is the image, and you can see that it's upside down, so what we say is it's inverted. And it's really important to say if the image is inverted or if it's the right way up. In this case it's inverted, it's the same size, and because we could project this onto a screen, it is a real image. For convex lenses like this, we always get real images. But if we use a concave lens, this isn't the case. So concave lens, the arrows go the opposite direction. We still have an axis through the middle. And I'm going to use the same object again, a person. So how do we draw these images? We'll have our focal principal focus points here. Same thing again, we draw a line from the top of the object to the lens, but this time because it's concave, it diverges. So it's diverging away, and we still draw a line from the top of the object through the centre, but this time we draw a dashed line backwards. And where those two lines cross, the one from the top of the object through the centre and the dashed line backwards, that there is our image. So our image is much smaller. Our image is smaller and it is not real. So what we say, it is virtual. And you get these with concave lenses. So the image is smaller, it is virtual, but you can still see it's the same direction, still upwards, so it's the right way up. Or you could say it's not inverted. Or you could just say it's upright, it's up to you. So that is for a concave lens. Remember, concave has this shape represented, convex has this normal arrow. And we can also draw magnifying glasses. You can draw magnifying glasses, ray diagrams of those. So let's draw it down here. Magnifying glasses are convex lenses. We have an axis through the middle, and let's say we're looking at the letter A. We're having a look at the letter A, so we draw an eye here. The eye's looking at that, and it's a convex lens. So it goes to the top and then refracts from the centre of the lens to the eye, goes from the bottom, goes up, refracts from the centre to the eye. From the middle, goes through to the eye. So what we do then is we dash these lines backwards, and that gives us the size of the object. So you can see how this letter A has got much bigger. Because it's dashed lines backwards, it is a virtual image. It's much bigger, and it is upright. But because it's a virtual image, we can't put this onto a screen. We can only see it, we can't use a magnifying glass and project it backwards. And there's an equation to know how much bigger it's got, and that is our image size, so the size of this image, the height of this image. The size of the image is our magnification times the real size of the object. So for example, let's say our object is 10 centimeters, but our image is 50 centimeters. What's the magnification? Well, the opposite of times 10 is divide by 10, so you get 50 divided by 10 equals our magnification factor, which equals 5, so it's got 5 times bigger, which makes sense. We've gone from 10 to 50. 10 to 50, that's 5 times bigger.